let's go ahead and talk about graphing quadratics. Okay? Graphing quadratics. Okay. So when graphing quadratics, we're going to have a bunch of different things that we need to keep in mind. And let's just start with the first thing, which is that the graph of a quadratic, and we discussed this earlier, but the graph of a quadratic is called a parabola. Okay. So when we talk about parabolas, we'll know that that is corresponding to the graph of our quadratic functions. And what we know is that these quadratics, these parabolas, have a U shape to them, right? So they have a what we call U shape to them. And I'll do the U without my usual kind of bar at the end so we can kind of see the shape. But we've been drawing these in the past, and you can kind of see what we were doing, right? So we were doing kind of like a U shape upward, or we're doing a U shape downward. So these have these U shapes, okay? Parabolas or these quadratics have U shaped graphs. Um, we also kind of want to take a look at what we call the vertex of a parabola, okay? So the vertex of a parabola is, in this case, a couple different things. The one, we're going to call this as the highest or lowest point on a parabola. Okay. So again, if I were to draw a parabola, let's say it opens upward, the vertex would be right here, right? It would be the, in this case, the lowest point. If you easily had a parabola that was opening upward, you would see the same thing, but at the peak, right? So this would be the vertex. Okay. So the vertex is the highest or lowest point on the parabola. The vertex is also going to be the point on the parabola where the parabola intersects its axis of symmetry. So what we know is that with a parabola, these things are going to be symmetric. So we have some axis of symmetry in our case right here, where the left and the right side are perfect images of one another, right? So if you took this point and you mapped it perfectly across, it would be right there. Same distance across from here to here, right? This distance and this distance is the same, and it's got the same y value. Okay, so there is this axis of symmetry. There's this line that allows for you to do kind of a reflection across it and get the same exact point at any moment, right? And this applies the same up here, right? So there is some axis of symmetry right through the vertex, and our points are going to have symmetry across that there, okay? So that is something to do with the vertex as well, right? It intersects our axis of symmetry. The vertex also is going to be the point where the parabola changes from increasing to decreasing or vice versa, right? So in this case, again, right, our graph is going down here. So this part, it's decreasing, and then this part, it's increasing. Right here was the point where that changed, right? From us going down to us going up. So the vertex is going to be that point where we kind of change from either decrease to increase, or if we're going opening downward, we're going to go increase to decrease. Okay, so something to keep in mind, right? The vertex has kind of a lot of different features for us and stuff like that. Okay, now the equation is going to be something else that we need to talk about, right? So the vertex is all good. We kind of have an idea of what these graphs are somewhat looking like, but the equation of our quadratics are going to be in the form of ax squared plus bx plus c. Okay, and we've seen this somewhat in the past. We really haven't focused too much on quadratics though, but you've probably seen the numberings in front. So this is our a x squared plus bx plus c. In particular, we're interested in the a, b, and c values. Okay, that's where we're going to be focusing. So we're going to set this up, right? Kind of like in descending power. So x squared first, x next, and then just the constant at the end. And depending on each value, we're going to have kind of something happening. So let's talk about some of the logistics here. So here, if our a value is positive, greater than 0, our parabola is going to open up. Okay, and if it opens up, what does that mean? That means the vertex is that going to be a maximum or a minimum? Well, if the parabola opens up, right, it would look like this, and therefore the vertex would be a minimum. Okay, so we want to kind of visualize, okay, it's positive a value, positive first value. That means it opens up. It's going to produce a minimum right here, so our vertex is a minimum. Okay, you can take a guess then that if a is negative, your parabola will open down. And therefore, if it opens down, your vertex is going to be a maximum. Right? Again, if we need to, we can visualize that. You draw a parabola opening downward. You look at the vertex right here. That's a maximum. Okay, pretty easy to see. So now we know what happens when the a value changes, right? If it's positive or negative. Now the value of a, if it's like 2 versus 5 or whatever, that's really just going to change the overall shape, whether it kind of gets a lot bigger or smaller here, right? It flattens out or whatever, but that's not going to change anything necessarily about it opening up or down, right? The fact that it's like a bigger positive number or whatever, we just need to know positive or negative, okay? We also are going to see that our C value is going to be corresponding to our Y intercept. Okay, and this should be pretty obvious because remember, y-intercepts are when x is 0, right? So if you were to plug x to be 0, both of these terms would go away, and you're just left with the c value, right? Which is the y-intercept. Very similar to how this works with lines, right? So with the equation y equals mx plus b, and I'll just put this here just so we can see it, this was our y-intercept, right? Because when you plugged in 0 here, you were just left with this. It's a very similar process, right? So C value is going to be our y-intercept. We've got a couple other things as well. So let's go back to that like axis of symmetry, right? So our axis of symmetry is going to be located at x equals negative b over 2a. Okay, so the axis of symmetry is going to be located at x equals negative b over 2a. So you figure out what a, b, and c are. Like I said earlier, these are kind of very important values for us. Once we know what each of those are, we can then start to find pieces of the parabola, right? So here we can find the vertex and technically the axis of symmetry, right? So let's include this as well. The vertex is located at, remember the vertex and the axis of symmetry are related, right? Because the axis of symmetry goes through the vertex. So the vertex is located at an x value of negative b over 2a. Well, how ironic, right? Makes sense. And then the y value would be whatever you get when you plug in negative b over 2a into the function, right? So if you have our equation up here and you find this to be, let's say, plug in your numbers, you get 3, you would want to go plug in x equals 3 into this to see what the outcome is, right? And that would be your y value. So we'll definitely have to plug in to get this, right? You're not going to just see it on the graph. Here you can plug in to get the x, and then you got to go back to the original function to figure out y, okay? So that's our vertex. Again, all of these we're going to kind of want to know, right? You're going to need to know negative b over 2a, know that this opens up or down, things like that. And then last but not least, let's talk about domain. In this case, the domain is going to be all real values for a quadratic, okay? So domain is going to be all real. That makes sense, right? Think about our shape we drew here. This goes out kind of in both directions. So you can get all x values if you're thinking about the x-axis here, right? You go always left and always right for infinity. So you'd get all kind of values for x. But for range, this is going to be restricted, right? So this is going to be restricted by the y value of your vertex. And this makes perfect sense as well, right? Again, I'm going to scroll back up to our picture. We cannot go below the vertex, right? There's no y values below this vertex right here. So we know that the range is going to be restricted, right? The y values are going to be restricted by whatever the vertex is. Note that we do have a value at the vertex, right? So if we're going to do range, it's going to be inclusive at the vertex because the vertex is a point on the graph, okay? So we'll do some examples like that, but just kind of a heads up. All right, so this is pretty much the majority of information that we want to know for our parabolas, okay? And again, let me just quickly do an overview. Our quadratics have these parabola shapes, right? So they're parabolas or U-shaped graphs, right? They either open up or they open down. They have a vertex which corresponds to either the highest or lowest point in the parabola, if we want to think of it like that, corresponds to the point where the parabola intersects its axis of symmetry. So we have this axis of symmetry almost like a mirror where if you looked on the left versus the right side, they're identical to one another, okay? So we have the axis of symmetry. The vertex is going to be kind of going right through that. And then we also have that being the point where our graph changes from either increase to decrease or decrease to increase, okay? So that's a point where we can have that shape change, right? From increase, decrease, decrease to increase. Then we talked about, okay, knowing kind of logistics about the shape, that's great, but what about the actual equation, right? Because we're likely going to be given our equation and want to know things about the graph. So our equation comes in the form ax squared plus bx plus c, okay? This is kind of like a standard form of what we're going to see. And we see that if the a, which is our leading coefficient, right, the value in front of the x squared, if that thing is positive, our parabola opens upward, we get a nice upward shape, and that tells us that our vertex is a minimum. Similarly, if we have our value of a being negative, that means we are going to open down, and we're going to have a minimum. So that would look kind of like this. Or sorry, we would have a maximum, right? We open down, draw that there, that's a maximum. Okay, so the a value says, hey, do I open up or do I open down? Do I have a max or min? The c value would be the y-intercept. That'll come into handy when we start to graph this. The vertex and the axis of symmetry have this relationship of negative b over 2a. So you'll plug in your values, figure out where not only the vertex location is, but you can draw then your axis of symmetry, and then you'll plug in to find where the y value of that is as well. And then last but not least, we could be asked something about the domain and range, and we would want to kind of think about what the shape we just drew was, that U shape. So here we saw with the U shape, the domain, the x values can kind of go left and right forever. So there's no restriction. But the y value did have a problem, right? Because it is a U shape, and so there is a point where the U no longer extends, right? So here, we stop here, right? Think of it like a bowl or something, right? There is a stopping point down at the bottom there. It's not going to protrude further into the table or something, right? It lays right on top of it. So great. These are the pieces of information. Now, we want to put this together and actually figure out what our graph's going to look like, right? So we're going to give some equation or whatever that may be, and we're going to figure out all of these pieces, okay? So let's do an example like this. Let's say I'm given y equals x squared minus 2x minus 15. Okay, we're going to want to find a bunch of pieces of information. First and foremost, we might start with is the vertex. Okay, so remember the vertex, we get this from doing negative b over 2a. Okay, so we go negative b over 2a. So remember, a is, in this case, 1. So this is 1x squared, right? You can imagine there's a placeholder of 1 there. B is negative 2. And c is negative 15. Okay, so the vertex occurs at negative b over 2a, which means negative 2, that's b, over 2 times a, 2 and 1. This is 2 over 2, which means the x value is 1. Now the y value for my vertex is going to be the function at negative b over 2a, right? Which is basically the function at 1. I'll go ahead and plug in 1 into my function, right? What do you get? You get 1 squared minus 2 times 1 minus 15, right? All I did was plug in 1 to my x value. And what do we get here? 1 minus 2, negative 1 minus 15 is negative 16. So my vertex is located at 1 comma negative 16. This is the coordinate. Cool. Okay, once you have the vertex, you have your axis of symmetry, right? So my axis of symmetry here is going to be x equals 1, right? It's the line x equals 1. I also want to get my y-intercept. Remember, the y-intercept is your c value. So pretty easy here. It would just be negative 15. So we can put it as a coordinate, 0, negative 15. What else? Well, what about our solutions or our x-intercepts? Well, we can get those as well, right? What would we do? Think about this. Maybe you factor it, right? Because it is kind of in a form where it might be easily factored. So let's go ahead and factor that. X squared minus 2x minus 15. We could factor this into x. So factors that multiply to 15 and add up to, negative 15 add up to negative 2. We would have 3 and 5. The 5 would be negative. The 3 would be positive. And so our solutions are x is negative 3, positive 5. Okay. Cool. Okay. So that is pretty much all of our pieces that we might have use of. Now we could go ahead and draw this if we wanted to. So again, think about this. And this is going to be a sketch. I'm not going to do it too perfect, but I'm going to do my best. Note the vertex is really low. So when I draw this, I'm going to have to get smart with this. So 1, negative 16, maybe that's way down here. I'm at a negative 3 and 5, so maybe like 5's out here, negative 3 is here. 0, negative 15 would be the y-intercept, so maybe this is at negative 15. And what I see is that connecting all of these points, my parabola, right, given this is the vertex right here, my parabola might go something like this, and make sure it actually goes through the point, right? So we got those, and remember these are also points too, right? Because these are x-intercepts, so here and here. And then the axis of symmetry, we don't necessarily have to draw, but we can do it kind of like this, like a dotted line just to show it. So this is the axis of symmetry. What that means is that at any height, this distance and this distance is the same away, right? So these are like a nice little mirror if you looked here to here and you reflected it, okay? So there we go. We got our parabola. We were to draw it just from the graph and these pieces of information, okay? Now, with this, we can also kind of do this the other way. So what they can do is they can give you a graph, and then you'd want to pull this information. So similar to like if I started here and I wanted to extract all of that information, it wouldn't be too difficult to do, right? Hopefully, we kind of see all the pieces. We can grab everything as needed. So let's try and do something like that here. Do my best to draw a picture that looks about right. Let's say something where maybe I cross at 3. This is negative 1. This is going to be negative 5. Let's say I'm up here at 6. So my vertex, right, I don't want to give too much, but the point would be here, and then my parabola is going to open downward like this, and downward like, it's a little hard for me to draw this one, like that. Okay, so here's what we got. We know what from this? Well, I do know that I have a maximum of, in this case, 6. So I have a maximum y value of 6, and that's going to occur at x equals negative 1. Okay. I also know I have a vertex, and that's located at negative 1, 6, so kind of the same information, right? Just presenting it slightly differently. I know that my function is increasing from, okay, well, where to where? Well, remember, increasing is when my graph is kind of getting larger. It's going upward. So here, I'm increasing all the way up until our axis of symmetry, which means I'm going to go from negative infinity up to negative 1. Therefore, I'm going to be decreasing on the other side of the vertex, right? I'm going to decrease from negative 1 up to positive infinity. What about my x-intercepts? Well, my x-intercepts are negative 5 and 3, right? Here and here. I'll also say f of x, well, let's say this. my axis of symmetry. And again, right, with all of this, they're going to ask you to kind of give these. Obviously, some of this we should have, like the vertex, whatever. Um, but some of it, we won't necessarily always just immediately think of. Like, for example, the maximum. We're not always thinking, oh, what's the maximum? We just kind of are focused more on the vertex. So this would be just a question that you might see on like the homework or quizzes, and they'll give you that, right? Same thing with increasing, decreasing. Like we kind of know it already, but you might not write this down if you were trying to solve this problem yourself. You might only do it if they were to prompt you to, and that's totally fine, right? So if they ask us for increasing or decreasing, it shouldn't be hard for us to do. We just might not write that ourselves to begin with, right? Axis of symmetry I probably would have done alongside the vertex 2 here, but the axis of symmetry is located at obviously x equals -1, okay? And then one thing they might also ask you is they might say, hey, when is like the height equal to some number, right? So in this case, let me say like 10. Well, hopefully here you could figure out when that's going to occur. So they'd say, oh, well, the height, the y value is 10 when x equals what? I'll look at the graph. When would you have a height of 10? Never, right? This graph will never get up to a value of 10, right? It stops at 6 and it goes only down there. So here, this would be like one of those D&E ones, right? You say, hey, it doesn't happen. It doesn't exist. But if it did exist, right? If they said, hey, what happens when this is like 4? Oh, well, you give 2 values, right? This point, whatever that is, would give you 4. And then this one here would also give you 4. Okay, so you might have some other x values, which presumably would be very easy to see from the table, and you could get that. Similarly, if you had an equation, you could solve when the height was 4, right? So for example, if you went back to the example that we did previously, if you had this, and they wanted you to find when, let's say, this was equal to 4, all you would do is take this, equal it to 4, and then solve that like we've solved all the other problems we've done in the past, right? You'd probably move this over, and then hopefully, based on how the problem's set up, you would be able to factor in some way, okay? So just an aside, right? I'm not going to go too crazy on that, but that should be pretty obvious for us to see, all right? So this is us graphing these quadratics, okay? We should hopefully be able to kind of see these shapes, find these vertexes, axis symmetry, max mins, right? Know if it opens up or down. All of that stuff is going to be definitely something we're going to be tested on and we want to understand, okay?